Now we are going to look at the problem in our next quiz. This is a problem out of our book. And what he is saying is you have this frame here with two arms and three forces, and it's not moving, which means it is in equilibrium. And you notice that the pivot point is around point C here. So if that's the pivot point and the thing is in equilibrium, we are going to use this tool out of our toolbox. The sum of all moments add up to 0. And we'll do the sum of all moments around point C add up to 0. And what he is asking you to find is this force pulling straight down. He tells you the other two. He doesn't tell you the force. You're trying to figure out how big a weight can this thing hold up and still be motionless. And I have put the answer at the bottom of the slide down here so you can check your work if you want to. So the way to approach this is first to find out how much moment is caused by each force. And we'll start with this 250-pound force on the left. I have drawn a triangle here. Remember that the formula for moment is force times distance. Here is the force, it's 250 pounds. The question is, what is the distance? And remember that the distance is from the pivot point perpendicular to the line of action. So here's the line of action, and there's the direction that is perpendicular to it, which means that it's that adjacent side there that will be the distance from the pivot point to the line of action. If you draw yourself another triangle here, so there's a 20-degree angle, the hypotenuse is 10 feet, you're looking for adjacent, so thinking about SOHCAHTOA, which trig formula uses the hypotenuse and the adjacent? Yep, it's cosine. Cosine is adjacent over hypotenuse. You're looking for adjacent, so you can rearrange the terms. Multiply both sides by h, in other words. So now we have h times cosine equals adjacent. And h, the hypotenuse, is 10 feet. The angle is 20 degrees, so we can write, when we write h cosine, we can write 10 cos 20. That will give us our distance, which is the adjacent side. And you can punch this on your calculator, 10 times cos 20. And you will get a number which is the distance. Now let's think about, is that a positive or a negative moment? That force is trying to rotate counterclockwise, which means that's a positive moment. Okay, now let's look at the 100-pound force. And I've drawn a triangle for you. One thing to think about, he gives you a 45-degree angle to the horizontal 0 line. I'm giving you a 45-degree angle up this way because I want to think about the distance to that line of action. How could I do that? How could I just move the 45-degree angle? Well, you know that this is a vertical line. This is a horizontal line. That means it's 90 degrees between vertical and horizontal. And if that's 45, then that has to be 45 as well, so that 45 and 45 can add up to 90. That's how I did that. 45-degree triangles are handy too because we know both sides are equal and both angles are equal. Anyhow, here's the triangle that I drew to think about that line of action and the distance. And we know the hypotenuse is 14 feet because he tells us that. So we want to go from the pivot point perpendicular to the line of action. And there's the direction that is perpendicular, so that means this vertical leg will be our distance that we're looking for. And we know the hypotenuse, we're looking for the adjacent, so again, which trig function would we use? Cosine is the one that uses adjacent and hypotenuse. And again, we can rearrange the terms. Hypotenuse times cosine equals adjacent. Hypotenuse is 14 feet. The angle is 45 degrees, so we could punch into our calculator 14 times cos 45. That will give us that distance. And is that force causing a positive or a negative moment? It is trying to rotate clockwise, so that will be a negative moment. You might want to keep track of that on your piece of scratch paper. Now let's think about this third force. This is the one we're trying to find. We don't know how big a force we can support and still be in equilibrium. Again, we know the hypotenuse. He tells us that is 14 feet. And now I can just draw this 45-degree angle that he has given us. And here is our force, our line of action. And the distance we're looking for is from the pivot point perpendicular to the line of action. So there's the distance we're looking for. And again, we want the trig function that uses adjacent and hypotenuse, so we can do cosine one more time. Adjacent over hypotenuse, rearranging the terms, we've got hypotenuse times cosine equals adjacent. Our hypotenuse is 14, our angle is 45, so we can punch into our calculator 14 times cos 45. That will give us that distance. And is force F causing a positive or a negative moment? It is trying to rotate that way, which is clockwise, so that means that's a negative moment. Now we've found all the distances and the forces that we know, and we can write the equilibrium equation, because remember, that's where we started. This frame is in equilibrium. It is not moving, so all the moments are going to add up to 0. And I've written at the top of the slide, the sum of all moments around point C equals 0. So the sum of all moments around C, what have we got? And remember, moments are force times distance. So starting at the left and working to the right, we've got that 250-pound force, and I hope you found a distance of around 9.4 or 9.397, and that was a positive moment. Now we'll go on to our 100-pound force. That's a negative moment because it's rotating clockwise, and I hope you found a distance of about 9.9 or 9.899. And we've got another negative moment caused by force F, and there's its distance, which is also 9.9 or 9.899. And those all add up to 0. All right, we've got to find F out of that glop there. So we've got all our forces times distances. If we want to solve for F, we want to get the F out by itself. So the first thing we can do, doing the same thing to both sides, we could add that term that has F in it to each side. They're still equal. And those two F 9.9s cancel out, and we are left with the two terms from the left, and we've moved the F 9 point something over to the right side. So that simplified it some, but we still need to get F by itself. Well, we can do the same thing to both sides again. Divide both sides by 9.899, or 9.9 if that's what you're using. Those numbers cancel out, and we are left with this big fraction, blah, 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 equals f. So now you can punch this big fraction into your calculator and see if you come up with the answer you should. If you don't come up with the number that you're looking for, which I posted on the first slide of this PowerPoint, check to see order of operations. Is something multiplying first when you wanted to do something else? What I like to do, I get really obsessive about parentheses, and I probably don't need to, but I just worry about I'm going to mess up. So I go paren 250 times 9.4, close paren, minus, I put two parens. I go a big paren around the whole thing, then a paren around the first two terms, minus a paren around the second two terms, then close paren, then all of that, blah, 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 divided by 9.899. I just find it safer. Another good thing to do is to try it two different ways, maybe with and without the parentheses, and see, do you come up with the same number? That's always a good test. If you do come up with the same number, that is probably the right answer. So there we are.